All right, so given, sometimes you may be given the solutions and you just have to calculate the solution of the differential equation, the partial differential equation, by using this, okay? You just have to know which one to use. So if you see ytt equals to, say, 9yxx, and y of 0t, y of 4t equals to 0, y of x0 is f of, let's just say this is 9 minus let's see, x squared. Oh, okay, just a minute. Sorry, should be 4 minus 2 minus x. Okay, so let me explain what's going on here. I explained that this type of equation is a wave equation, that if you take the second derivative of the position, think about the string that's tied at the end, and you're trying to vibrate this string. If you take the second derivative of the y position, then that's the acceleration in the y direction, right? And it's basically saying that the way, the concavity, how it's bended, the more bended it is, the more force it will be acting on this string, right? So yxx computes the bending, and times some constant gives you the acceleration. But what's really here, hidden here, is that it's really F equal to ma, and m is here, but that m is divided over here, and it's along. Somehow it's in this constant. Okay. All right, and here y of 0t equals to y of 4t equal to 0 means that for any time the position at 0 and 4 are 0, which means at 0 and at 4 this position doesn't change, meaning that the endpoints are always fixed. Okay. And then let's say y of x0, when initially at time t equal to 0, you have the following displacement. So let's say you have this. So that'll be like you take a string and you pull it at one point, so it's bended like that, and you release it, and then it's going to go back and forth, right? And that's what we want to figure out. Now, it's actually interesting to graph the solution after you solve this. If you solve this and you see the graph of the solution, it always maintains this type of solution. It will do like that, and it will just go back and forth, maintaining this cusp here. Do you call it cusp? What's the point that's not differentiable? And that's not really the same thing as the reality. If you really took a string and you released it, then because some friction, and actually you lose a lot of energy due to sound, right? And because of that, it gradually becomes reaches equilibrium. Here it doesn't. It will always, because we don't assume any kind of friction, when you release it, the solution will tell you that it goes back and forth without any loss in the amplitude. Okay, so that's kind of not what you would expect in the real life, but still it's useful. So this is called the wave equation. And let's just say the initial speed y prime or yt x0 is 0, so that we don't have to calculate this one. All right. So suppose you're given this problem, and you're also given this formula in the formula sheet. First, you have to locate the derivatives locate the formulas and compare it and see if it matches. You have two derivatives in t, two derivatives in t, two derivatives in x, two derivatives in x. So that means we are talking about the same wave equation. So let's say you figured out that this is the equation that you want. All right. Then we just compute this and plug it in here, and that's pretty much it. Something's not right here in this solution. I think I did. Oh, yeah, yeah. Sorry, this has t in there, and the entire thing should have sine of n pi x over L. So I made a mistake in copying the formula. Okay, so given this formula, how do you solve this? Well, you just use the formula and that's it. Yes?
On here it says Bn is equal to 2 over An times pi.
Okay. So right. 2 over An times pi. Thank you. That's also wrong. Okay.
The same for A or no?
No. An and Bn are different because when you do the matching of the coefficients, to get the Bn, you have to match with the derivative, and at some point when you differentiate, this An pi pops out, and this L also pops out. They cancel, resulting in this one only. Okay. All right. So let's do the solution now. The solution is you calculate A and calculate Bn. One of them is 0. Which one? Okay, is this fx or gx?
FX.
Fx. And this one is
GX.
gx, if you compare it to that one, okay? So which one is 0?
Bn.
This one. Gx is 0, so this interval will give you 0, okay? So that means you just have to find An, and once you find An, you plug it in here, and that's it, okay? So let's do that. Now we have to find An, which is you take 2 over L. What is L here? L is 4. L is the length of the string, right? If you look at here and you look at here, there's L here, there's 4 there, so that must mean that L is 4. Okay? I mean, just by matching each equation carefully, you can figure out what L is, you can figure out what fx is and gx is, and after that, all you have to do is just calculate. That's it. All right. So you have this 2 over 4, and then integral 0 to 4. Fx is 4 minus absolute value of 2 minus x. And then you have to multiply by sine of what? N pi x over 4. Okay. So that's what you have to do. N pi x over 4. Sounds easy, right? The only trouble is that now you need an integral that's split into 2 parts because of this absolute value. So what is 2 minus x absolute value? Maybe I should use I don't have a very strong cut here. What is 2 minus x absolute value? So if x is less than 2, 2 minus x is positive or negative?
X is less than 2. Positive.
Positive. So what does the absolute value do?
Nothing.
Nothing. If x is bigger than 2, what happens? This will be negative, therefore it makes it positive. How do you make a negative value positive?
Negative.
You put a negative in front. Okay, that will make it positive. So that's what 2 minus x is. And therefore, when you do this integral, you should split the integral to an integral from 0 to 2 and 2 to 4. And once you have that, and then you will need to use these two different definitions of the absolute value of 2 minus x. and therefore, and afterwards you should calculate. Okay, let's just go a little bit more. What is 4 minus 2 minus x then? 4 minus 2 minus x is when x is less than 2, this will be 4, it says 4 minus 2 minus x, it doesn't change. But if x is bigger than 2, then it will be 4 minus negative 2, so it will be 4 plus 2 minus x. Okay? So it will be these two functions. And of course, you should simplify further because 4 minus 2 is 2, so this will be 2 plus x, whereas this will be 6 minus x. So that's what we will use. Okay. So integrate 1/2. First one is 0 to 2. This one, from 0 to 2, we follow this one, which is 4 minus 2 is 2, so it's 2 plus x times sine of n pi over 4x dx. And then plus, I'll just put it here, plus 1/2 integral from 0 to 2. This one is 6 minus x, right? So you put 6 minus x sine n pi over 4 x dx. Okay, each of these should be computed using a tabular integration. Let me erase this part because I don't need this anymore. Let me compute it here. So for the first integral, you need plus minus d integral, and you have 2 plus x, and then sine n pi over 4x. Now if you differentiate this, it's 1. If you differentiate this, it's 0. If you integrate this, that's negative 4 over n pi cosine n pi over 4x. And integrating again, it's negative 16 over n squared pi squared cosine, no, sine n pi over 4x, and plus minus plus, and doing that and that will give you the following integral. It will be 2 plus x multiplied by negative 4 over n pi cosine n pi over 4x. And then negative will be positive, so it will be plus 16 over n squared pi squared sine n pi over 4x. And then you will have to plug in the endpoints 2 and 0. That's for the first one. For the second one, let's see, I guess we can skip a little bit. Because really, the only thing that's different from this one to that one is instead of 2 plus x, you have 6 minus x. That's the only difference, right? And the next, it'll be 6 minus x and then negative 1. So there's this and positive 1 here, but I'll replace this by 6 minus x, and this will be negative 1 in front. So for the second one, you'll be getting negative 6 minus x, 4 over n pi, cosine n pi over 4 x. And then for the second one, you'll be minus 16 n squared pi squared sine n pi over 4 x. And for this one, you'll be plugging in 4 and 2. Sorry for skipping this, just to save time. But if you want to check, you can do the same tabular again. And you'll find out that I did this right. Okay. All right. Now let's plug in 2. If you plug in 2 here, you get 4. cosine n pi n 2 n pi over 4. Okay, that's going to be causing some trouble here. This will also give you something. Oh, it's a mess. It's very, very tough. Much more involved than what I anticipated. Okay. All right, so I don't have any more choice but then to delete everything. I'll just erase everything and start writing on top. Okay. So let's start writing one by one. First, when you plug into it's negative 4 times 4, so it's 16 over n pi. Cosine n pi, and if you plug in 2 here, 2 and 4 cancels, right? So you get 2. And then again, if you plug in 2 here, 2 and 4 cancels, and you get sine n pi over 2. So you get plus 16 over n squared pi squared sine n pi over 2. So that's what you get if you plug in 2. Now when you plug in 0, cosine 0 is 1 and sine 0 is 0. So that one's gone, so that's good. This one survives and we have to take care of it. Okay. If I plug in 0, it's negative 8 over n pi. And cosine of 0 is 1, so that's it, right? Okay, so that's what you get from the first integral. Okay, now in the second integral, it's negative. Plugging in 4 gives you cosine n pi, which is negative 1 to the nth power, right? If you plug in 4, it's negative 8. So it's negative 8 over n pi. And this is negative 1 to the nth power, because you get cosine n pi. And plugging in 4 here gives you sine n pi, which is 0. So that's all you get. Okay. And then finally, when you plug in 2, this becomes 6 minus 2, which is 4. 4 times 4 is 16. So negative 16 over n pi cosine n pi over 2. Okay. And then when you plug in here, you get negative 16 over n squared pi squared sine n pi over 2. Okay, I hope something cancels. Does something cancel? Something cancels, right? What cancels? What canceled? These two cancel, right? Good? Okay. However, the sign term, they double. Minus minus is plus, so they double. All right, so let's write that down again. Okay. All right, so still, a good thing is that this and that's the same. So if we factor these two out, you get minus minus, that's plus. So you get 8 over n pi, 1 minus negative 1 to the nth power. Yes?
Did we lose the half before the integral?
Oh, thank you. Everything is
sorry.
over 1/2. Okay, so, sorry. 1/2. Thank you for pointing out the error. Everything has 1/2 in front. I forgot that. Okay. So if I multiply the 1/2, this will be 4. Also, these two are the survivors. They double because they're the same thing, but because of 1/2, you come back to the same thing. Okay, so that's what AN is. Now this is somewhat it's not as what we like it to be, because sine n pi over 2 is definitely a number that oscillates between what, 0, 1, 0, negative 1, 0. So when n is even, this will be 0. When n is odd, it will be either positive 1 or negative 1, right? So that's what happens. What about this one? What happens if this is even? It'll be 0, right? And it will be 2 if n is odd. Okay? So you see that when n is even, they both give you 0. So you should try to say something more about this. Okay? So you say that because this is 0, if n is 2m, it will give you 0. Okay. Now, if n is 2m minus 1, what's going to happen? This will double. Right? This will be odd. If it's odd power, it's negative 1. 1 minus negative 1 is positive 2. 2 times 4 is 8 over n pi. That's what you get for the first one. And this one, what is sine 2m minus 1 pi over 2? Let's look at it. So here's pi over 2. Here's 3 pi over 2. Here's 5 pi over 2. Now 1 pi over 2, that corresponds to when m is 1. If m is 1, it's 1 pi over 2. When m is 2, if you plug in 2 here, 2 times 2 minus 1, that's negative 1. If m is 3, it's going to give you that. Okay? So what do you see? If m is odd, you get positive 1. If m is even, you get negative 1. So can you write this down as negative 1 to some power? What?
2n minus 1? 2m?
If it's 2m, that means it's always positive. If it's 2m minus 1, that means you're taking odd power of negative 1, so it's always negative 1. I want this to alternate, whether m is negative, m is odd or m is even.
Just n.
M
plus 1.
M plus 1. Okay. That's what it is, right? You see it? If m is 1, 1 plus 1 is 2, negative 1 to the second power is 1, exactly as we have. Okay? So that's what we get. So we have, in that case, it's plus 16 over n squared pi squared over negative 1 to the m plus 1. And because we want to just replace all the n by 2m minus 1, we'll just rewrite this as 8 over 2m minus 1 pi plus 16 2m minus 1 squared pi squared negative 1 to the m plus 1. Or if you want, you can delete this and make this as minus. Because losing one of the negative 1s, you can rewrite this as negative 1 to the m times negative 1 to the first power, and negative 1 can be brought out here. Okay? So that's what we have. And then all that remains is to use this formula now. That's your an, right? An is 0 when n is 2m. An is 2m. An is this thing when n is 2m minus 1. So all you have to do now is to put it here. So the final answer, according to this formula, is sigma. Now we're going to use m now. M from 1 through infinity of a 2m minus 1 cosine a times, what's the value of a? I erased it, but yeah, see, original question was given as ytt is 9 times yxx, right?
Yes.
So a squared is 9, so a must be 3. Okay, so it's 3 instead of n, you're going to put 2n minus 1 pi over 4 t, and then sine 2n minus 1 pi x over 4. Okay, see how I just wrote down the odd terms only? Instead of using n, I'm using m, so I only get the odd terms. Why is it possible to do that? Because the even ones are 0, so we don't need to put it at all. Okay. And finally, if I quote that and put it in here, that's the final answer. So the answer is sigma m from 1 through infinity of 8 over 2m minus 1 pi minus 16 over 2m minus 1 squared pi squared of negative 1 to the m times, and I have to copy this and after the cosine 3 2m minus 1 pi over 4 sine 2m minus 1. Oh, so there's a t, I forgot t here, pi x over 4. Okay, so that's the final answer. Okay?
That's it?
Yeah, that's it.
Oh.
Easy, right?